Hi guys, and welcome to this our video on what is a graph. You're going to say, hold on a moment, I know what a graph is. I've been drawing them since I was knee-high to a grasshopper. Yeah, not this type of graph. It doesn't have an axis, doesn't have little annoying squares, it doesn't have those units that drive you mad. It's going to be fun. Now, my name is Darren from Maths Guru. Thank you very much for watching this video. If you are not being forced to watch it by a teacher standing over your shoulder, even if you are, do me a favor and subscribe. No one watches maths videos. If you subscribe to my YouTube channel, turn off notifications if you want to, but there might be some good stuff coming. It just lets me know that someone out there is watching these videos and I'm not actually sitting in a room talking to myself, which is really weird and probably going to get me in prison at some point, but moving on. So what am I going to look at today? Well, always behind me you will see the notes, and these can be downloaded from maffsguru.com because your summary book is going to be key for this particular stuff. We're going to look at what a graph is, why it's important to me, and understand more terminology. If you watch my previous video, you will have seen that basically, yes, there is stuff here that talks about vertices and edges and degrees. Now we're going to look at loops. Right, my daughter's 3 and I've got here we go loop-de-loop, but we'll move off of that altogether. Every one of these videos needs your summary book beside them, because the more you put in the summary book, I promise you, the better you are going to be. Now, in my previous video, we looked at the bridges of Königsberg problem and Euler. And Euler basically turned around and said, well, look, there is some sort of theory here. We can actually make these complicated diagrams that you can see there into such much easier, where we have things called vertices and edges, right? And basically a graph is a pictorial representation of some sort of network or some sort of real world problem, but made much simpler here, because we don't actually want to be drawing bridges every time. We're not studio artists, are we? We're not, fine artists. We like dots and lines. We don't want to make it too complicated. So being able to turn complicated real world situations into simple diagrams that are about connections is effectively a graph. And why on earth would we need to use graphs? Well, as I said in my previous video, I love theme parks. More on that later. I don't want to be going to a theme park and going backwards and forwards and backwards and forwards and backwards and forwards along the same path to get between rides. It just doesn't make any sense. I want to choose the most efficient, the best way of getting around. So if I can get around a particular city, or if I can get around a theme park without repeating particular paths or edges, then all the better for me. A postman, for example, also isn't going to want to go backwards and forwards up and down the same street. It's not efficient use of time. So this is massive, right? If you go into a career in logistics, for example, a lot of money in logistics, then that's what they deal with all day. What's the fastest possible way of getting from A to B? So, right, it's a very short lesson, this one. So if you're still listening, that's good to know. But what are we going to do here? I'm just going to introduce a little bit more language. This here is a graph. It basically connects things together. It's brilliant, all right? So here it could be 4 towns, A, B, C, and D. What I notice is the lines that connect them are basically the connection. So in that situation, there is one direct road between A and B. But I notice here that there are actually 2 connections between A and D. Well, if you think about it, if I was to go from the city to, say, Richmond, there's more than one way I can go. And that's very much why graphs are great. We can show that without drawing on all those silly road networks. The interesting one here is this. That seems really pointless in real life, doesn't it? It seems like a roundabout, just going round and round. But every now and again, we may meet a situation where we have a loop. And that thing there is called a loop. Yeah, why? Because it looks like a loop. Right? And what that means is it is a connection from one point to the other that doesn't really go through any other point. Yes? Trying really hard to think about where a loop might be useful in life. Can't think of one at the moment. Do you know one? Put it in the comments below. So that's a loop. We know that this point here, those little A, B, C, D, they are called vertices. A single one's a vertex. We know that there is called an edge. But what about multiple edges? Well, actually, I've already talked about that just here. So when I've got more than one way to go between 2 places, and in this situation between A and D, those 2 lines there are called multiple edges. And you're going to say, oh, really, this is already so dull. It does get better, I promise you. But what I'm trying to tell you now, and I'll say over and over again, is have your summary book near you. Download these notes from maffsguru.com, cut them out, stick them in, whatever makes it easy for you. But I have yet to see a student do badly in graphs who don't have a really good summary book with all the definitions, particularly later on, right? We're starting gently. Don't get too excited, right? So this is the language. Now, there is a bit of a gotcha with a loop. If we go back to our previous lesson where we talked about degrees, and I said to you, every single graph you're going to do, work out the degrees of the vertex. It's going to make your life so much easier. So I'm going to do that here now. So if I look at B, we would write that down as degree of B equals, how many ways are there into B? There are 2. So that's degree B is equal to 2. If we look at A, we have the degree of A is equal to 1, 2, 3, 4. Awesome. What about the degree of D? And again, the language, the notation here is really important. Degree of D is how many ways are there going into or out of D? There are 2. Now, this is the gotcha. All of that was basic so far, but this is the gotcha. If we look at C, I want you to imagine whenever you're doing this, you're just drawing a small box around C, anything with a loop, and just ignore the rest and look at the number of ways that are going into C. There's 1, 2, 3, and actually 4. So the degree of C is actually 4. Now, why is that a gotcha? Well, actually, the gotcha is most people can do that, but they then get confused with the number of edges. Because how many edges are there connecting C? And that means how many roads, not how many roads are coming into or out of, how many roads can I drive along to get to C? And actually in that situation there's 1, 2, and in that situation the loop counts as only 1. So if that was a situation there, the number of edges coming into C is actually only 3, and that's a gotcha. So again, in your summary book, write down the edges for a loop, that a loop counts as 1 edge, but it counts as 2 degrees. And then there's the 3 degrees, which is a pop group, and I'll really show my age now, and I'll stop before it gets embarrassing. And again, I told you this was going to be a really short video. Yes, the reason being is because it's just language based at the moment. Write it in your summary book. My name's Darren. Thank you very much for watching from Maths Guru. If you haven't done so, subscribe, tell your mates, tell your teachers. Hopefully this stuff makes sense. One of the things the rest of my videos have is humor, believe it or not. Yes, I know, I think I'm a little bit funny. You might disagree, then stop watching the videos. No, don't stop. Keep watching the videos. I'm going to say goodbye now. Take care, guys. See you again soon. Please stay safe. Bye-bye.